Fala galera, good afternoon everybody. So happy to be here again. My name is Matheus. I work for a company called ThoughtBot. You might know us from our open source work. If you use gems like FactoryBot, Shooter Matchers, maybe you know our blog. That's us. And today I want to talk about production data, and we'll start by telling you a story. And this one is about a migration. So say we have a notification system, and we are adding a new feature where we can schedule notifications to the future. So instead of just sending them immediately, we can send them now in the future. So we do all the work on the front end, all the work on the back end, and we, of course, add a new column to the notifications table called sent at, which is a timestamp to say when this notification was sent. But we also backfill the historical data, because if all notifications were sent immediately, then all the notifications that exist, the sent at time is the same as the time that they were created. So we open a PR, it gets reviewed, it gets merged, and you just go to sleep happy with your work. And then, boom, in the middle of the night, you wake up. Your phone is ringing, your email inbox is full of messages, the APM quota is exceeded. What is happening? Well, it turns out that when we merged the PR, the deploy started. And it went fine for the worker server, but then it took a while to run in the web server. And eventually, the deploy failed. And it failed because of this line. What happened is, in production, there were millions and millions of records of notifications. So this line of code took a while to change. And eventually, the deploy was interrupted by a timeout. So now we have the workers running new code while the web server is missing the new column. And now we have code that reads that column, and we have code that writes to that column. So every time a job tries to reference that column that doesn't exist, it breaks. So you have to figure this out during the morning, a lot of coffee, you rush to the console to fix this, you run the data migration manually, and if you think that there should be a better way to do this, and of course the answer is yes. The problem with this was that we coupled three things in one deploy. We did a schema change where we added a new column. We did a data change where we backfilled the column with the existing values. And we also add new behavior, the code that reads and writes to that column. And each one of those behaviors depend on the previous one. So the solution here is to split that in three different parts. First, deploy only the schema change, add the new column, then do the data change separately, and then have the second deploy have the new code that accesses it. And this thing in the middle that does the data change, that is called a data migration. There are several gems in Rails that can do data migrations, but today I want to talk about data customs. Not because I created it, but because it has something extra that we'll explore later. So if you haven't seen a data migration, it's basically like a schema migration. It lives alongside those, but they don't change the DB structure, but it changes the DB, data. So here's an example of a data migration, exactly what we did before. But the advantage of a data migration is that you can run them separately from the deploy processes. So you avoid that problem altogether. So again, deploy in different parts. First, add a new column with the first deploy, then write a data migration and backfill that column. And only then you deploy the new code that uses that column. And now when it tries to access it, everything works, everyone is happy, and developers are happy ever after. So the first lesson here is, production data often has a different size than you might expect. Take that into consideration. Next story. This one is about ghosts. So this time we have a forum-like app, so we have users, and users can comment on stuff. But the important part is that users can delete their accounts, but that comments will still remain in the system. So there's an optional relation here. The problem is that this led to code like this, where we don't know if the user is present or not, so we have a lot of we have to backfill the data. Like when the user's name isn't present, we have to have something like this. And this leads to code that is verbose, ugly, duplicate, and very bug-prone, because if you forgot about this, then everything breaks. So someone had an idea. What if we created a deleted user, and we find all the orphan comments, and we assign those comments to this deleted user? That way, the association is no longer optional. We can assume there's always a user, and the code will be greatly simplified. So we learned a lesson. We will write a data migration for this. We create this deleted user, and we find orphan comments, and we updated all of them. We are also going to deploy this separately. So we run the data migration first, backfill the column. Now we can refactor all the views, and when they access that column, boom. What? It breaks again. How could this happen? We even tested our data migration. Well, turns out that we made another wrong assumption here. We assumed that all the orphan comments would have nil user IDs. But if you look closer to our models, our has many association doesn't have a dependent nullify set, which means that when users are deleted, the comments remain still pointing to the ID of that user that doesn't exist anymore. So when we try to find orphan comments, we try to check if it's nil, but it's not nil. It's just pointing to a user that doesn't exist. So we get nothing here. And our test never caught this because we used factories that had perfect data. So how could we have prevented this? I asked myself this question a while ago, and I was scared of production data. You never know what's in there. Then I thought, what if we could test in production? Now hear me out, I know. Because I think this is where data custom shines. With normal data migrations, you just run them, and I guess you just hope it works. But what happens if it doesn't work? Boo. What happens if it doesn't work? What if an error is raised? What happens with your data? Is it in the right shape? Is it half migrated? You don't know. So with data customs, instead of just shipping the migration code, there we go. You also ship a verification step to confirm that the work was done correctly. I'll just keep going. So this is basically a test, and we will check if the test passes. If it passes, then yes, your data migration ran correctly. But if it didn't pass, then we will roll back all the work so your data is not left in this weird in-between state. So this is what it looks. You define your data migration code in the up method, and then you define a verify method. And here, like I said, we are building a test, but we have to be careful with tautological tests. Tautological test is something that is true by definition, not because it's proving something. For example, consider this method to sum two numbers. We could write a test for it that is tautological like this. And it's tautological because the assertion uses the same code as the implementation. And so this doesn't prove anything new. And while this seems simple, it's very easy to write a test like that in real life. And they are dangerous because they give us a false sense of safety. The test passes, that means that it works, but not exactly. A way to break the tautology here would be to assert the result, not the calculation itself. So back to our data migration. We could check if here, after the data migration runs, there are no comments with no user IDs, but that would lead to the same problem. We are writing a test that is verifying the same thing as the migration. We would not have caught the bug. A solution here, one of them, and there are several ways to test this, would be, for example, check each comment if they have a user association available. So if user is nil, is different than the user ID is nil, because in this case, you get those orphan comments. And you can collect all of those IDs and raise. And if there's still orphan comments, then we raise and the migration rolls back. Or you can also just use where missing, which takes into account both the new user ID and the dangling user IDs. And this also catches our bug. And with this, we would get an error while running the data migration, not after all the other code touches it, not when a user is using the application, way before all of that. And then we can fix it, and no bugs to the users. You can fix it before you ship new code, and everyone will be happy ever after. So the second lesson here is that production data often has a different shape than you expect. Whenever humans touch data, it gets these weird scenarios that you didn't expect. Debugging an issue like this can be very tricky because our development data often lies to us because it's just perfect. Everything is correct. And you might want to access the production console, or maybe you want to get a dump from production to check that data in your computer. But if you're following laws like LGPD or GDPR or HIPAA, you cannot do that. It might be illegal to do it. So what? Data customs helped us to catch problems at the migration time, but what if our development database looked like the database in production? And that's the second gem that I want to show you today. It's called Evil Seed. It's a gem to get dumps from production, but they will be anonymized, so it's safe to use. So before I show you the gem, let's imagine an app. This app is a productivity app, so there are users can log in, so there are sessions. Let's say users have checklists have many items, and let's say users can bookmark links and also assign categories to those links via categorization model that is polymorphic. So pretty complex scenario. And in production, there would be a bunch of data, a bunch of relations, and that would be hard to get a dump from production with that. So what Evil Seed does is let you pick one root record or several root records, and it will trace the associations to you, and you don't have to think about it. So after you install the gem, you just configure it. So you call this configure method, and then you define what's the root model or the root models you want. So in this case, let's say we start with the users, and you can filter like just the active users or just a particular user, and you would get a dump for this user only. But let's say for this example, we'll use a dump from all the users. So after that, you pass a block, and you can exclude some data if you don't want to. So let's say we don't need the sessions because sessions have IPs, and we don't want to deal with that. So you just exclude that association. You can exclude, for example, active storage models, like you don't need files in your system, so just ignore that. You can limit the association, so let's say for each user, I don't want more than 1,000 records. Or if you want to be specific, I don't want any user checklist with more than 10 items. You can do that as well. So if you ran this as is, you would get a dump from production, but all the personal data is still there. So there's a second step here. After configuring the root models, we'll anonymize them. And to anonymize, it's really simple. Just call the anonymized method with the model name and a block. And inside this block, you call a method with the attribute name you want, and you pass a value. So for example, here we are creating, every checklist will get a random name. This can be random, like I showed you, but you can also use faker to get something that is more real looking. And you just do that for every model you want. And the attributes here will be used instead of the original values you had. But if you want, you can also customize, and that allows you to use the existing attributes as well. So for example, let's say you need unique email addresses. You can use the ID from the attributes to get unique emails for each users. Or you can also use faker unique method that will guarantee that the emails will be unique every time you call. Another use for the customized method is when you have a polymorphic model like rich text, and you can just check the record type here, and you can do something different for each record type. So let's say for notes, you want want it to be a paragraph. And for checklist items, maybe you want something smart, and maybe you have a fallback for all the other models. And now, if you ran this, you would get something like this, a SQL file with a bunch of insert statements that you can just load in your development database. Whether it's Postgres, MySQL, or SQL, doesn't matter. And all the values here are anonymized now, so they are safe for you to use, but the shape of the data is still there. And hopefully you can just load this development, catch bugs, and be happy ever after. So third and final story I want to tell you, this is happily not something that has happened. It's more of a cautionary tale, something to pay attention and not let happen in our apps. We've talked a lot about data at rest, migrations, development databases, but modern Rails apps also send data to third-party services. Maybe you are sending data to logs, maybe you have analytics, maybe you have a chat feature using LLMs. That means that you might potentially be sending user data to third parties. And like I said, this might be emails, username, phones. And like I said, if you're following laws like HIPAA, this might be even illegal. So the third gem that I want to show you is called Top Secret. And it's a gem that will help us filter data before we send it to third parties. It works like this. You have like a string, you send it to Top Secret, and it will give you back the same string, but without the personal data that was there. So the API is really simple. Just call the filter method and with a string, and you will get a result back. And if you call output on that, you get that string that I showed you with the filter text. You can also get the mapping of the labels and the original values that they had. And this is especially useful if you're having like a chat, LLM chat feature, where you can just send those labels, and the LLM will just use them as if they were real. And if you take the mapping that you had and input on the restore method, you can restore the values back, so that it kind of looks like the LLM had the data, but it didn't. So the workflow would be something like this. You have a user send a message, you pass it to Top Secret, and the LLM just receives a label. It will use that label and produce a response, and you pass it back to Top Secret that restores the original values. What is cool is that from the user's point of view, they just send a message, stuff happens, and they get a message back. They don't even know anything is happening, but their data is not leaked anywhere. So how does it work? Well, there's two sides to Top Secret. First, there's the syntactic filters, and those are triggered by the structure of the text alone. Think of emails or phone numbers or credit cards, like just the format of it. And there are the semantic filters. Those take into consideration the context and the meaning of things, so people names, places, company names. So syntactic filters are simple. They use regexes. So if something looks like a phone number, it is a phone number. It's pretty simple. And you can add your own custom filters if you want to as well. Semantic filters, on the other hand, they try to understand the meaning of something. So with these two sentences, they would know that jobs here, even though it's the same word, refer to different things. And there are no LLMs involved in this process, no API calls. This is all backed by a node, almost forgotten technology called machine learning. So in particular, it's using Mighty, which is a machine learning tool from MIT to extract information from text. So this is the Ruby API. You just pass in some string, and you get those things back. So it even has a confidence score, so you can know how confident it is about something, if it thinks it's really a name or not, maybe. So if you put this in a chart with cost and flexibility, regex would be very low cost. They are pretty fast to run, but not very flexible. While an LLM like ChatGPT or Claude is very costly and very flexible, while a tool like Mighty, which uses machine learning, is somewhere in the middle. It's more flexible than a regex, but you don't have to jump all the way to the cost of an LLM. So instead of setting all of those protected information to external service, hopefully Top Secret helps you just send you the labels, and now data won't be leaked, and everyone will be happy ever after. So the third lesson here is that production data needs boundaries. And this was supposed to be the end of the talk, but I noticed that I had 10 more minutes, so there's a bonus section. So these are 3 other gems that I want to show you. They are kind of in the same headspace, but they didn't have time to get their own stories. First of all, strong migrations. This is basically a linter for your migrations. We talked about data migrations today, but even normal schema migrations can be dangerous. For example, if you're using Postgres and you are adding an index to a column, this will lock your table while the migration is running. So if you have a large table, this can be a problem. So for example, the migration is running, indexing a long table, and maybe users try to access your application, create records. They will be blocked because the database is locked for writes. So they just won't be able to use your application. You have this downtime for a long time. So this is unacceptable. So strong migrations will complain about adding an index like this, and will tell you that the correct form is to add an index using the concurrent algorithm, which allows to both index the table and to write it at the same time. So no problems. And there are a lot of other dangerous operations that you might know. So things like removing a column is dangerous, or renaming a column, or changing whether a column is nullable. So all of this can be dangerous, and strong migrations will complain and will tell you the right way to do it. Next gem, one is called Blazor, and it's a gem to explore data with SQL. So in theory, it's used to explore data like charts and visualize how it's your data, but the important part for us is that it has this feature called checks, where you can just write a SQL query to find data that is weird in production. So, for example, ensuring that all ratings have an user associated. And you can have this check run like every hour, or maybe every day, or even set a check that will send you a notification, an email, or a Slack message every day at a certain time if it finds something weird. And you get this dashboard as well, where you can see the checks and run them manually, edit them. And last but not least, we have console 1984, which was mentioned before today. So basically, the idea here is that every person that accesses the console in production could read private data, and your private data might be leaking through a person, not through your app. So with console 1984, before accessing the console, you have to tell who you are and why you were using the console. And what is cool is that if you have encrypted data, it will stay encrypted, so you can read anything. And if you need to read that, you have to manually decrypt it. And when you do that, it will ask you why you need to decrypt this data and where did you get consent from the user to do it. So you have to tell it that. It also protects external services. So if you have like a Redis associated with cache, it will also encrypt cache and not let you access that. So if you try to read cache, which might contain private data, it will just raise, and you have to decrypt manually and tell the purpose and have the consent. And you also have the companion gem called Audit 1984, which is a tool to audit all the console access. So you'll say, this person accessed the console to do this. These are all the commands that they did, and is this valid? Is this dangerous? And you can flag it accordingly. Okay, so we had 3 different stories today. The one where we built a scheduling feature, but we didn't consider the size of the data. The one where we changed how users were deleted, but we didn't fully consider the shape of the data. And where we integrated with third parties, but we didn't set boundaries to the data we are sending. All of those 3 stories were not about users handling data. It was about us, developers, handling data in our relationship with this. Rails is this amazing framework that has a lot of tools, but it doesn't solve everything for us. It has schema migrations, but it has nothing for data migration. It has seeds for local data in development, but nothing to get done from production. It has parameter filtering, so you filter your parameters, but nothing for free text and external services. The thing that we have to change here is that we have to try to treat data as a first-class citizen. Think about all the tools that we have to help users manage the data, forms, params, controllers, models. All of that is just the interface that we use to manage data. But in the end, our app is the data, and we need to treat it with the respect that it deserves. That's it. That's what I had for today. I hope y'all like this.